The Earth's crust is made up of many different types of rocks. All rocks contain one or more minerals. Rocks and minerals are mined to help make things around us, from the large stone slabs used in buildings to the tiny pieces of metal in phones and jewellery. Rocks are grains of minerals clumped together. Rocks can be hard and rigid, or soft and crumbly. A mineral is a solid that occurs naturally. It is made up of chemicals and is present in all sorts of materials, including our bodies. In your workbook, write down what a mineral is and the difference between a rock and a mineral.
Minerals are useful to us. There are many everyday objects made from minerals. For example, this table salt is from a mineral called halite, which is sodium chloride. And this padlock is made from a combination of copper and zinc, which come from the minerals chalcopyrite and sphalerite. And this can is made from aluminium, which comes from the mineral bauxite. In your workbook, have a go at matching the everyday items to their main mineral components and see just how useful minerals are to us all. It has been said that if you took all the rocks and minerals away, we would be living in a cave. In fact, not even that, more likely living under a tree. We've made use of rocks and minerals from the Stone Age, about 3.4 million years ago, when our ancestors used materials such as flint to make tools, through to the introduction of metal tools around a few thousand years ago. During the Industrial Revolution in the 18th and 19th centuries, iron and coal became the critical minerals of the day. And this heritage can be seen here at Brumbo, one of the largest iron and steel works in North Wales, that closed in 1990.
As technology has evolved, we have become more reliant on a new group of critical minerals, which include lithium, cobalt, graphite, silicon and rare earth elements. Almost every part of modern daily life relies on minerals, often mined thousands of miles away. From our cars to mobile phones, wind turbines to medical devices, modern society is quite literally built on rocks. Once a mineral deposit has been found, it has to be extracted from the ground either by open cast quarrying or underground mining. After minerals have been extracted from the ground, they are converted to a form that is useful to us. This usually involves removing any unwanted impurities and processing to increase the concentration of the economic mineral. These new critical minerals are becoming even more important, as the world is expected to need 4 times as many critical minerals for clean energy technologies in 2040 as it does today. The critical mineral supply chain is dominated by China, which makes the world market for them quite volatile. This means that jobs and industries in the UK rely on minerals that are vulnerable to up and down markets and political events at a time when global demand for these minerals is rising faster than ever. The UK government has a critical minerals strategy which sets out a plan to boost our own capability in critical minerals. There is mineral wealth stretching from the Scottish Highlands to the tip of Cornwall, along with a long-standing history of expertise in refining and material manufacturing. The strategy aims to work with other countries too, which will create opportunities for UK companies overseas. Now, have a go at answering the questions on critical minerals in your workbook. There are over 2,000 active mines and quarries in the UK, producing a wide range of minerals, including construction aggregates, building stone, coal and industrial minerals. We are going to focus on the formation and use of 5 critical minerals.
Graphite occurs when metamorphism, which is increased heat and pressure from the earth, happens to organic rich sedimentary rocks, for example, coal. The organic part provides the carbon from which graphite forms. Graphite also occurs in metamorphic rocks and in meteorites. It's used in making the core of pencils, lubricants like grease, as well as in paint because of its water repellency. It provides a protective coating on surfaces too. It is a common element used in the production of the lithium-ion batteries and is a good conductor of electricity. Graphene sheets are 100 times stronger and 10 times lighter than steel, making it useful in the aerospace industry.
Lithium is found in ores from igneous rocks, as well as salts in brine pools. The largest producer of lithium in the world is Chile. Lithium is important in the manufacture of personal technology devices and electric cars. It is highly reactive and easily conducts a current through a battery, allowing them to be rechargeable. It is also much lighter than other metals used in batteries, such as lead.
Cobalt is used in lithium-ion batteries such as this one, and in the manufacture of magnetic high-strength alloys. Cobalt is found in sedimentary rocks and is often produced as a byproduct from the production of copper, nickel, silver, gold, lead and zinc.
Tungsten is often extracted from granite, an igneous rock. Around half of the tungsten is used to produce hard materials, tungsten carbide, with the rest being used in alloys and steels. Its high melting point also makes tungsten suitable for aerospace and high temperature uses, such as electrical, heating and welding applications. The UK Government Critical Minerals Strategy is helping to ensure access to these critical minerals for the future. But what is the life cycle of a critical mineral? In the next lesson, we are exploring this very question.